Shiva, you are going to show step by step running the Python scripts, right? For this model, prices
Yeah,
forecasting model.
yes,
Okay,
sir, yes.
go ahead. Go ahead.
Yeah, I will also show the
First,
Excel
you
sheet.
map the Excel tasks here for this particular Python script. Take the Excel is the source to map it. Take one task and show the Python script code. Then later on you execute it, and before executing show the input file also. Open the Excel sheet. This is the data I am supplying to Python script. Then later on you show the output file generated by the Python script. The same way you have to verify step by step.
Yeah, so for data preparation, we have the script data generate script.py. So this will create the like test data for to our model. We'll see here you okay, got stuck here.
Pardon?
This wait, I stuck here.
Okay, okay.
Yeah,
You
I
can
need
fix them.
to okay. So first we will see the generate data script. This one. So here we are doing data generation for our car price. So here I am importing pandas as PD and numpy as NP. Here I am taking the random values. So here I have taken for reproducibility from numpy np dot random dot seed 42. So this is a number where you can give any number. So no issue for reproducibility because we are running so many times. So that's why I have taken some number. The number of records, I'm going to take number samples as the variable 1000 data entry points. Then I'm going to generate the car IDs to track for like testing purpose. So car IDs variable, and these are the variables. It will keep on increasing with the +1 for the records. Then I'm going to take the car names as a variable. So these are some car names I have taken like Toyota Corolla, Honda Civics. So these are the some car models. Then I have taken the year from 2018 to 2024 recent data. So years is the variable. It will store this data like from 2018 to 24. Then I'm going to generate the present price based on the year, based on the year logic. So present price is the list. So for a year in for year in years, if year is greater than 2022, then this is the price range in between the 18,000 to 25,000 because these are the new cars. So that's why it has taken high price. And if the year is uh, less than equal to 2020 and in between 2022, then the car price should be 12 lakhs to 18 lakhs. Else part, the price should be 5 lakhs to 12 lakhs. This is the range for the older cars. After that, I'm generating the selling price with 5 to 35% of depreciation rate from the present price. In general way, I have calculated it from the general way perspective. So selling prices is the variable where it will store the list of all the present price So for present price, in present prices, I'm considering the depreciation. So depreciation as the variable, it will it will give the selling price in between the range of 5% to 35. That is nothing but 0.05 to 0.35. Then selling price is calculated based on the uh, present price into 1 minus depreciation. That will be calculated as selling price based on the present price. Then in the selling prices, I'm adding selling price. Then after that, I'm taking the kilometers driven as a variable that is considering in the range in between 5,000 to 1,50,000 on our samples of the data. So this is the about fuel type. So this is the fuel types variable where I'm going to choose the random from these choices: petrol, diesel, CNG, and electric. These are the choices. So it will take the random value and it will assign with the sample step data. Similarly, seller type also. Seller types as a variable will take assign the random value from these two choices and assign it to the number of samples of data. Then transmission also is the variable. It will take the random of the value from these two choices and it will assign to the number of samples randomly. All these fuel type, seller type, and transmission. Then owner is also the feature where we are taking the these are the choices we have. We created for 0 is the first owner. It is representing as a first owner. 1 is second owner. Then 2 is for third owner. And 3 is more than 3. That is the fourth choice. And it is assigning to the number of samples of data. Then after that, we're also making some kind of real data. So for that, we are introducing some missing values also in specific columns. So for that, this is my function, introduce issues as a function. So these are the my parameters, data and missing percentage. I have taken 5 and the negative values also percentage is 3. Then I am going to introduce in the data with this module numpy dot array for the data. That data type is object. And next I am going to take the variable for this how much uh, number of items in my data. It is stored in the total. Then after that, I'm going to missing values. So I also need to count missing count from this total of the data into missing percentage by 100. That it will take the missing indices as a variable and it will randomly choose. Yeah, this is the function, random choice function, where it will take the total, then size is missing count, then replace equal to false. Then I'm going to loop for IDs in missing indices. If any is data with ID, that will take as a none. Then similarly for negative values also, the same logic will apply. Then after that, once we find missing values and negative values, we are going to see apply the missing and negative values in the specified columns that are selling prices, present prices, and kilometer driven. So these are the 3 columns. I'm going to apply the missing and negative values only. So in selling prices, this is the introduce issues, selling prices, and the missing percentage is 5. The negative percentage is 3%. Similarly, for present prices also, the present prices, this is the missing percentage of the parameter, that is 5, negative percentage is 3. Similarly, for kilometer driven also same. Then after that, I'm going to create the data frame with the data columns. So DF is the PD.data frame with the data columns: car ID, car name, year, selling price, present price, kilometer driven. These are the data columns. So it will create all this. Finally, I'm going to save in the CSV file. that is test car data 2018 to 24 realistic CSV file. Then it will print the data set created with years. Finally, if we executed the script, if it is success, then it will print this message. Now I will execute this data generation. Under Jupyter Notebook.
You're running the script now.
So this data set is created. Test car data 2018 to 24. So once the data is ready, now we are going to do some data pre-processing on this data. So this is the data pre-process script. So we need to load our data set, which we have created in the previous task. So this is our file path. We need to mention the file path name. Then we are going to read the CSV file with this file path variable. Then after that, we are going to check the missing values in our data set with this help of this df dot is null function dot sum. So it will verify and it will check the missing values in our data set, and it will display the missing values also. Then after that, once we find missing values, we are going to handle that missing values with the help of by replacing missing values by using median of the particular data column. So because we have taken only the missing values from this kind of columns only, so we are going to handle the missing values also with the particular columns by replacing the missing values to this df selling price dot fill now function. This is the function where it will replace the missing values, which is grouped by the year, then selling price, and by taking the median value dot transform median. Similarly, in present price, if we have missing values, we are also fill the missing values by fill now function, which is grouped by year, present price, and we are going to transform the median value. Similarly for KMS driver. So it will print missing values filled for this columns, particular data columns. And after that, we are going to check and handle the negative values also. So for first, we need to identify the negative values. Then we are going to convert that negative values with a positive. So for that, here we have taken negative values as a variable, and we want to identify the negative values in the data frame columns, selling price, present price, and kilometer driven. So that is less than 0. This is the condition. If the condition is true, we are going to store all the negative values in the negative values variable. And we are going to print negative values before correction. Once we find the negative values, now we are going to convert these negative values to the positive. So for that, for column in selling price, present price, KMS driven, we are going to look for each column, and we are going to apply the lambda with if x is less than 0, else x. This is the condition. So it will convert the negative values into the positive for this data columns. So it will correct and will give the positive values. So after that, we are going to verify the price reasonability in between the 2018 and 2024 car models. So here we are going to take unrealistic prices as a variable, where if the data from variable year is greater than equal to 2018, and that selling price is less than present price. then it will print the unrealistic records. So these are the some unrealistic also it will create because of we are taking the data from ChatGPT through Python script. So we are also need to check any unrealistic values it will create it. Then we need to replace this unrealistic selling price values with 70% of the present price. So this is the condition. In the data frame, we are going to take the year as a variable that is greater than 2018, and the data frame selling price should be less than always present price with the 70% of the present price, and the remaining is 30%. That is selling price. That is equal to present price of the 70%. This is the condition we are taking. Then after that, we are going to handle the selling price that is greater than present price. So this is also not possible in real time because the present price is always greater than the selling price. But we need to check this also. If any day price selling price is greater than present price also, we need to find and we need to delete this that kind of data also. So this is the condition. Invalid price records is the variable where it will check the any selling price is greater than present price. Then it will print invalid records also. Then we're going to save this invalid records in separate file also. That is the invalid price records.csv file. Then after that, we are going to fix if the selling price is greater than present price. If we found these invalid records, then we are also going to set the selling price that is 90% of the present price. We are filling these values also. Then finally, we are going to do the validation of the whole script by checking any missing values even after pre-processing the data, and also checking the negative values after processing all these things. Then finally, we are going to save the clean data in a cleaned car data CSV file. So now I will take this. I will run the script. So it is showing missing values before processing. So we have missing values in these three columns: selling price, present price, and kilometer driven. Then it is missing values filled. Then negative values also is available in these three columns. The negative values are corrected. Then finally, it is created one invalid price records. That is invalid selling price values are there, and clean data for CSV file is also created, latest file. So after this, we are going to see a visualization of the data with the different variations.
Can you show the Excel for each Python script and explain the task or subtask there and come back to the script explaining the code snippets? And then your plan is going to be mapped to the Python script. That's where we should explain it, right?
Sorry, yeah. So here, yeah, we will see in data pre-processing script. We'll see.
You can discuss all the tasks at one stretch, then come back to the script and explain the code snippets related to that tasks, subtasks.
Oh, so if you see in data pre-processing, these are the tasks. First, we need to import necessary libraries. and we need to load the CSV file. Then we need to check the missing values, and we need to do handling the missing values. Then we need to do some check and handle the negative values also. Then we need to verify the price reasonability, like if any unrealistic values are there in between this 2018 and 2024 cost model. And we need to handle the selling price that is greater than present price. These are also some invalid values, selling price values. Finally, final validation script. After that, we are going to save in a clean data set for modeling to the same up to task 9. These are the tasks, missing values, checking missing values, handling missing values, then checking and handling the negative values, then verify this price reasonability also for these car models, then handling the selling price greater than present price, then final validation and saving the clean data set for modeling. These are the tasks for step 3 data preprocess script. Now we will see step 4 data visualization. Yeah, step 4. These are the tasks. So in step 4, so task 1 is basic data understanding and exploration. So we need to understand basic data understanding. Then we need to unique count the values. What are the price unique for each column? We need to count, and also we need to see distribution analysis like histogram plot for numerical feature, task 3. Then task 4 relationship analysis by using scatter plots and box plot. Then task 5 finding the outlier detection also using box plots for numeric features. Then correlation map analysis by using heat map for the numerical features. Then trend analysis. These are the 7 tasks we have for data analysis step. The same way. So here, these are the common steps: importing the liquid libraries and loading the data set, updated clean data set. After that, these are the tasks involved, like basic data understanding. So here we need to understand the basic data, how it looks like by taking df.shape with rows and columns also. Then it is going to print the df.info function. It will print the first 5 rows and last 5 rows also. Then we are going to see the summary of the statistics with the help of data frame.describe function. Then second one is unique values and counts. So for each column in data frame.columns, we are going to find the unique values, and we are going to remove any non-numeric columns before correlation. We are selecting that kind of values and store in the data frame numeric variable. After that, we are going to see the distribution analysis for the numeric features. So these are the numeric features: the selling price, present price, kilometer driven, and year. These are the numeric values. So for this, we are going to see some distribution analysis by using this plot graphs for I variable column in enumerate numeric features. We are going to plot the x and y axis for this numeric feature values. For the title is distribution of the each column. Then we are going to see the fly.tight layout will give values, and it will show the all the values distributed for this numerical features. And it will save the image in feature distribution.png file. Finally, similarly, relationship analysis. We are going to plot for the relationship analysis for like numeric feature values by taking this scatter plots or box plots also, taking the present price and selling price. So between the box plot, between the selling price versus present price. Similarly, we are taking this scatter plot for the columns here, selling price, how it is, the trend looks like, the relationship between features. And similarly for kilometer driven and selling price. This is the one scatter plot. And finally, the image is saving in relationship analysis PNG file. After that, box plot for the categorical features. This relationship analysis for numerical features, then box plot for categorical features. So these are the categorical features: fuel type, selling price, and this is the title for this: selling price by fuel type. And finally, we are saving under selling price fuel type of PNG file. After that, we are going to find outlier detection also in the selling price column, present price column, and kilometer driven. And we are taking this subplots with the axis 1, then variable 3 data frame, and we are taking the title as box plot of for each column, and we are going to taking the layout of the x and y axis, then plotting the graph for the outlier detection and saving the file in under outlier detection.png file. After that, we are going to see correlation analysis for the numeric columns. So this is heat map function we are taking for the correlation analysis only for numeric columns only. We'll plot the graph for the correlation heat map for the numeric values and save the file in correlation heat map PNG file. Then we are also going to see the trend analysis between the year and selling price columns. Then it will give the year-wise average selling price and the average selling price also. And finally, we are saving in the yearly price trend PNG file. That is all about the visualizations and analysis of data for numerical features. I will copy this. After the scripting, I'm entering data analysis. So this is the basic data understanding. We have 1000 rows, 10 columns, and the data set information, like 1000 entries, and the data columns also. All are non values. So there is no any non values are not available. And it is also showing first 5 rows. And these are the unique values in this categorical features. So these are the distribution of the selling price, present price, and the kilometer driven and a year. So the data is distributed across uniformly. Then this graph is relationship between selling price versus present price. This x-axis is present price, the selling price is y-axis. So here it is showing linear because whenever present prices are increasing, then also the selling price is also increasing. Then this is graph is selling price versus year. So if year is 2018, the selling price is less. But if year is 2024, latest model, then the price is very high. This is kilometer driven. So the data points, it is distributed across all from 20,000 to 1,40,000 kilometers. So these are the points it has distributed across. So this is the selling price by fuel type box plot. So it is showing electric is has the higher selling price. It's a more than 1.25 above. Then CNG is little bit lower than the electric. Then CNG and petrol almost equal with the selling price. Then diesel is somewhat higher than the petrol and CNG. But electric is showing among all the fuel types, electric for the for vehicle fuel type is have the high selling price. So these are the box plot for selling price. Then box plot of for present price and the kilometer driven. And this is the correlation heat map where we need to analyze and correlate what are the futures. If you see this here and the present price, it is showing 0.89 positive correlation in between this year and present price. Then for year and selling price, it is showing 0.86 correlation relation. So that this is proportional. If the year is more, then the selling price somewhat is. Then for selling price and present price, it is almost showing 0.95 positive correlation. Then this is present price and this is year is 0.89. So we have the maximum correlation heat map for this features is year and selling price, then present price. So these are the three features is the mainly impacting the selling price value. After that, this is showing year-wise average selling price in 2018 in between 2018 to 24. So the average selling price when 2018 is very low, then when it keep on moving, 2018 is also showing same kind of average selling, but 2020 it has dramatically increased from 0.5 to 1.2. Then slowly from in 2021 it is slightly decreased. Again from 2021 to 22, the average selling price of car is increased very high. So this is the graph for average selling price in between the 2018 to 2024 of the data. After that, we are going to see feature engineering and selection, where we need to load the data set and we need to do encode the categorical features into the numerical values. Then we are going to drop unnecessary columns that are not going to impact our model. Then we are going to create new features. Then we are going to drop the redundant columns. Then we are going to save the processed data. This is about feature engineering. Then in feature selection, these are the tasks. Defining the features and target variable. And we are going to generate the correlation heat map. And finally, we are going to save the featured selected data for training our model. So this is feature engineering script. The same task, loading the data set, cleaned car data, then we're identifying the categorical columns. Then after that, we are going to apply the label encoding for this categorical features. For each column in categorical columns, this is the categorical columns. These are the categorical columns. For each one, we are going to apply the label encoder, and we are going to transform this, converting categories into numbers. And finally, we are storing the encoder values under the label encoder column variable for the future purpose. Then we are dropping the car ID column because this is not much needed to predict the values. So if car ID is present in df.columns data, then df.drop column car ID, which in place equal to true. That get current year. So current year is the variable where it will get the date time of the from the now function with the year integer variable. Then we are going to create new features, car age and the depreciation rate. So car age is going to calculate from the current year variable, current year from this current year minus year variable of the data frame. Then depreciation rate will be calculated based on the present price minus selling price by car age plus 1. So this will give the depreciation value. After that, we are going to drop this original year column because we are created car age. So there is no need to mention the year. So we are going to drop the year column. And finally, we are going to save the processed data file under the processed car data CSV. So this is feature engineering. So the latest process data saved under processed car data CSV. After that, we are going to select the features that are mostly needed for our price predicting the price model. So these are the tasks. Define the features and target variable, and we are going to see the generate correlation heat map in between the target and features, and we are going to save the latest feature selected data set. Similarly, the same thing we are going to see in the feature selection. So here we are uploading the data set that is update latest processed car data. Then we are dropping unnecessary columns like car name and selling price because we are going to predict the selling price. So that's why we are removing this value also. Then we are taking the selling price as the target variable under by variable. Then we are going to see the correlation heat map from the future correlations between the target variable and the futures, in between the futures and target variable. And we are going to find the most futures that are going to impact our predicting the car values. And finally, we are going to save the updated values under this latest future selected data CSV file. I'm going to copy. And this will give latest future selected data. This one, latest future selected data, where it has also the car age and the depreciation rate features as well. After that, we are going to see the model selection and the training. So we are going to load the latest future processed selected data, and we are going to load the original data set that containing the target variable. Then we are going to match the selling price back to the future selected data set. Finally, we are going to validate the successful matching, and we are separating the future as the X variable and target as the Y variable. And we are going to perform some training and testing data split as 80% is training and 20% is for testing the testing purpose. And finally, we are going to save training and testing CSV files for the process, next process. This is a split test train data script. So we have loaded the future selected data CSV file. Then we are loading the original data set, processed car data set. We are matching the selling price. Then we are checking if selling price is now included. Then it will, if it is not included, then it will give the value error. After that, we are going to define the futures as the X variable. It will store the futures except selling price. All the futures are stored in X variable. Under the target variable, selling price only will be stored under the Y variable. Then we are going to split the data into 80% as training data and 20% as the testing data. So these are the four variables: X train, X test, and Y train and Y test data. And we are going to split through the train test split function for this X and Y, where test data is 20%. That is means to 0.2, and the random state is 42. So this is for reproducibility because we are running so many times. So that's why we have taken this number, random state number. You can take any number. Then finally, we are going to save the split data sets under the X train CSV and X test CSV. Then similarly, Y train CSV and Y test CSV files. So this is about data splitting activity. Copy. And I will run. Now we created data splitting for training and testing. So these are the our CSV files for training and testing purpose. Now similarly, we are going to train the model. These are the tasks. Read the training feature and the target variable. Then we are loading this X train and Y train CSV files for reading the features and target variable. And we are initializing the linear regression model, and we are training the model and training data. So once we train the model and training data, we are going to save the model using job leak tool for further uses. That is a train model py script. Here we are loading the X train and Y train, and we are going to initialize the linear regression model. This is the linear regression model function. We are taking under the model variable, and we are going to train under the model dot fit for the X train and Y train. data frames. Now we are going to save the model under the job_lib.dump model as the variable. Then linear regression model dot pk1 is the name. This is like a model training and saved the latest file, pk file. Press copy the training the model. Press execute here. So our model is training completed and saved the latest file, linear regression model, pk file. After that, we are going to evaluate the model. Evaluation of the model. Here are some tasks are involved. We are going to read the test data, X test CSV, Y test CSV, and we are going to load the pre-trained model, which we have trained the previous task. That is the linear regression model. Then we are going to use this model for the prediction on the test data. Then finally, we are going to calculate the performance metrics. These are the performance metrics like mean absolute error, mean squared error, and the R squared score, then root mean squared error also on the test data. Finally, we are printing the like model performance metric values also that we are going to see under this evaluation model. Then we are loading the test data. So now we have trained the model and the training data. Now we are going to evaluate the model and the test data. So now we loaded the test data set CSV files. Now this is our saved model in the previous task, linear regression model pk1 file. And we are going to make the predictions and the test data files that will save under the Y prediction variable. Then we are going to calculate the evaluation metrics. So mean absolute error for the Y test Y predicted value, then mean squared error, Y test Y predicted variables. Similarly, root mean squared error and also R square value from this Y test and Y predicted variable. Then it will print the values here. This is the evaluation of the model on test data CSV files. Now it is showing these are the metrics values. So the mean absolute error, we are getting 73,823, and the mean squared error is a very so have a large value. Then the R square value is 0.9658%. Means our model will predict the variance of the car price up to 96% of the value. Then we are going to see the predict the model with graphs also. Like we have already did the X test and Y test, and we have already trained the model, but I have included the graph to show how the actual and the predicted selling price values are plotted across the X and Y axis. So I will show that one also. For extent of the script, we'll show the graph also. So this is the graph, the actual and predicted selling price for this linear regression model. So almost this the values are near to the straight line, linear line. some values far away a little bit. So we need to fine tune and we need to retrain the model for this. Those are values are far from this. Also, I have created one UI also. Let us show that one also here. Under I will show this one also. This is some UI based for users. They want to predict the car price values. This is index.html file where we have several the car price prediction values, the label original price, then what is the car age and what is the depreciation rate, then what is the kilometer driven. These are the some input labels. The users so need to give the details for these input labels. Then the model will predict the output values. This is the result.html file where it will predict the results based on the given values of the user data. And this is our model.pk1, which we have trained model. Just now we have seen trained model. These are our test and train.csv files. Now I'm going to, this is our Python script with the
One
class
minute, 1 minute.
application.
Hold on. Let us not discuss Python script. Let Rahul be there in tomorrow's session. Tomorrow you can discuss it. We'll stop here. And this is a code review session for your model design activities. Okay. So let us name it as code review session for Python. Okay. I'll stop recording and